Good evening, everyone. Today I'll be discussing directional derivative. So, the definition of directional derivative is that let f be a function of two variables x and y, and let u is equals to cosine theta I plus sine theta j be a unit vector. So then, the directional derivative of f and the directions of u denoted by d of u d sub u of f is d sub u f of x and y is equals to limit f of x plus t cosine theta y plus t sine theta minus f x and y as t approaches to 0, provided this limit exists. So, in calculating directional derivatives, by this definition is similar to finding the derivative of one variable by the limiting process. A simpler working formula for finding directional derivatives involves the partial derivatives f of x and y and f of y. So, as you can see, there is a theorem of directional derivative, which is theorem 13.9. If it says that if f is a differentiable function of f, x and y, then the directional derivative of f and the directions of the unit vector u is equals to cosine theta I plus sine theta j is d sub u f of x and y, which is equals to f sub x of x and y cos theta plus f sub y x and y sine theta. So, directional derivative, there are infinitely many directional derivatives of a surface at a given point. So, one for each direction is specified by u, as you can see in this figure. So say for example, finding a directional derivative of f of x and y, which is equals to 4 minus x squared minus 1/4 y squared at 1 and 2 in the direction of u is equals to cosine pi over 3i plus sine pi over 3j, and this is the called directions and this is the surface. So, in finding the directional derivative, so because f of x and f of y are continuous, so f is differentiable and you can apply this theorem. So we have this. So what we are going to do is substitute the derivative. So we are given this one. First is the value of f of x. We're just going to derive x first. So we came up with negative 2x cos theta. And next, the derivative of negative 1/4 y squared. So we came up with negative y over 2 sine theta. The partial derivative, getting the partial derivative, So next is evaluating a theta is equals to pi over 3 and x, which is x is equals to 1 and y is equals to 2, produces, using the theorem, this one, we're just going to substitute the given value. So, since we have 0.1 and 2, so we substitute the value of f sub x. So our x is 2, negative 2 and 1/2 plus 1/2 2, because our the value of theta is pi over 3, and we're just going to multiply. So, and next is plus -1, because the value of y is 2 all over 2, which so we came up with -1. And then our theta is pi over 3. We're just going to simplify sine pi over 3. So we have square root of 3 over 2. Next, simplify. So we have -1 minus the square root of 3 over 2. So for clarification, cosine, so the value of theta is pi over 3 here. In unit circle, the value of cosine pi over 3 is, which is the 60 degrees. So we have 1/2, and therefore the value of sine pi over 3 in unit circle, we have pi of square root of 3 over 2. So that we came up the final answer, -1.866. So this is the illustrations of this example. And that's all. Thank you.